for joining us today for our webinar on poultry baselines. This discussion is applicable to all those who are involved in generation and interpretation of diagnostic testing data. Today you will learn why generating a baseline is important and the factors to consider when inputting and interpreting the information. We will cover understanding the why and how of generating a baseline, general immunology as it applies to baselines, first steps, understanding test validity and basic statistics, and specific details on how to build a baseline using XCheck Plus and Microsoft Excel. So let's begin with some background on why this may be beneficial for you to learn to do.
There are several advantages to using and keeping a baseline of your flocks. These include, number 1, comparing new data with historical information previously archived. This helps to give your titer values context and makes interpretation easier, and is probably the most important reason to use a baseline. Number 2, it is a good first alert to overall potential lab issues. Overall increases in titers can indicate trouble with equipment or inconsistencies in techniques. Number 3, elevated titer values may suggest infection, and this is easier to catch early if you have context with which to compare the values. Number 4, low titer values may suggest improper vaccine administration or immunosuppression. And finally, number 5, it is an excellent way to monitor management changes and to establish epidemiologic trends. If you change your handling of the flock, for example a new vaccine or different vaccine timing, you may see subtle changes to the baseline, which you wouldn't otherwise notice.
So for the lab staff, you may not interpret the results yourself, and you may be kind of asking, how is generating a baseline important to me? Companies are always looking for ways to reduce expenses and maintain flock health. And serology does provide useful information in many ways, but tracking the results over time is a much more sensitive way to detect changes than just looking at several single time point evaluations. This extra information can make management decisions a little bit easier, and this makes the testing more valuable without increasing costs, as the only cost of building a baseline is the time to generate and maintain it. Anything that adds value to the lab testing should be important for lab personnel. So for a moment, I'd like to go back and review the immune system of poultry and how these titer values relate to actual health of the flock. We're going to go over a couple of quick definitions and a quick immunology review. Poultry are in the field exposed to antigens through vaccination and natural exposure, and the immune system produces antibodies, which are shown here as the Y-shaped structure, to these antigens, which are shown here as the colored structures. This helps to fight off the disease, and it also protects the bird from getting the same infection in the future. A titer is the amount of antibody present in the bird for the disease which we are testing specifically. One important note is that hens pass along some short-term immunity called maternally derived antibodies or innate immunity to their offspring. This is passed along in the egg to the chicks as fully formed antibodies, and these protect the chick from diseases until the chick can begin to generate its own protective immunity or acquired immunity, which typically takes a few weeks. Now that we understand how antibodies are generated, let's correlate these to titer levels. I think the best way to go about this is to look at an example of an ideal time to vaccinate a young chick. So a vaccination is a controlled exposure to an antigen, allowing the animal to produce antibodies to a specific disease without the risk of getting sick. And we tried to time initial vaccination of young birds to correlate with the time in which their maternal antibodies are beginning to decay or wear off, which is a natural occurrence. The better our timing is, the more effective our vaccine can be to provide the chick with continuous protection from any diseases they may encounter. In our example here, the red line represents the maternally derived antibodies, and the green, the antibodies generated in response to a vaccine. The titer levels are how we quantify the amount of antibodies specific to a disease to which the poultry have in their system. So moving forward with this example, if we were to vaccinate this chick too early, we would be moving this green line to the left, and the maternal antibodies, which would be still quite high at that point, would render the vaccine ineffective. If we vaccinate too late, moving the green line to the right, we risk the chick having an infection before acquired immunity can be established. So determining ELISA titers and trends can help us pick the best time to vaccinate, and also allow us to detect responses to the actual vaccine and to disease challenges in the field. Here are some other examples of different groups of poultry and the unique reasons why we measure titers in each one. Let's begin with specific pathogen-free or SPF birds. These birds have eggs which are typically used in vaccine manufacturing, and the birds themselves may also be used for epidemiologic studies. They are not vaccinated, so they should have no antibodies in their system for the specific diseases of which we're looking. Field exposure because of this can be devastating in these birds, as they have no prior immunity to use. And so we check titers very often to assure that they haven't been exposed to any sort of disease. In adult breeder or layer birds, vaccine is expensive and time-consuming. Timing of testing and vaccination is important to make sure the bird's immunity doesn't wane to a dangerous level before revaccination, as we saw in the previous slides with the chick. Revaccinating too early can be wasteful and ineffective, and so measuring these titers helps us pick the optimal time for revaccination.
There are other reasons for measuring titer values. In breeding birds, it is important that parent stock have strong antibody levels to allow for adequate passage of MDA to their chicks. We measure these to assure that the offspring will be protected. Also, the presence of antibodies at higher levels than we expect can indicate field exposure to a disease. Finally, we look at them for disease detection. A humoral response can be detected as early as 2 weeks post-vaccination. When using live vaccines, we recommend sampling 4 weeks post-vaccination and 6 to 8 weeks post-vaccination when monitoring an inactivated vaccine. Having a baseline will help to distinguish this normal vaccine response from a disease challenge response.
So next we'll discuss choosing when to use serologic testing. You want to address real health questions and apply your knowledge by selecting the correct serologic test, considering sample size, timing, and interpreting the results correctly, and we'll go over each of these points. Let's begin diving into addressing real health questions. What we mean by this are health questions which will really be applicable to the health and the production of these birds. So some examples would be, what is the cause of a clinical disease we are seeing? When should we vaccinate this flock? Do we need to show freedom of infection? Did our vaccine and our protocol, our administration of the vaccine work? And finally, in epidemiological research, we want to know what our goals are for that research before we begin. So when we say apply your knowledge, we want you to understand and consider the following aspects of selecting the correct serologic test. Understand the validation of the assay, basically testing that that test works well, the sensitivity, specificity, any sort of cross reactions that you may want to look out for, and then repeatability of the test. And these are all factors that will apply to the design of the assay. And this is where selecting the correct serologic test comes into play. You'll want to keep in mind sample size and timing, and always interpret your results wisely, using your baselines to identify trends and monitor changes in your protocols over time. So we've covered the background. Let's get into the generation of the baselines. The first steps that you'll always look at are interpreting the IDEXX ELISA for validity, the number of samples, the mean titer, standard deviation, and coefficient of variation, and assuring that all of these are in line with your expectations. Any abnormalities here could indicate that your test results are inaccurate. This can actually throw your baseline off and do more harm than good. Let's begin with assay validity. You always want to check your positive and negative controls against the insert and use the most current version of the insert. If your control values are out of range, then your assay is simply invalid, and you should always troubleshoot before rerunning the assay to make sure that you don't waste time, reagents, or money. The XCheck Plus software will flag invalid controls after it is read, and you should always keep an eye out for this. You'll want to make sure that you're examining a statistically significant number of samples from each population or flock. And the more variable you expect your results to be, the more birds that you should try to look at per flock to get representative results. And you also want to choose your sample size with disease prevalence in mind. If you were, for example, given 2 samples to choose from a flock of 10,000 birds, adding these samples into your baseline may actually cause more harm than good, as these samples may not be representative of the general flock and may be being tested for a specific disease problem or reason. Let's move on to the mean titer. This is an average of all the titers seen in the flock, and it's sort of meant to correlate to the approximate average titer of the average bird. So with a large sample size, then this mean titer will be more reliable, and you can either look at the G-mean or the A-mean. XCheck will provide you with both, and you can choose which one you prefer. The baselines will really vary depending on a number of factors like breed, placement, the vaccine program being used. And so a mean titer really is only going to be useful if you know how much expected variation you're looking at. A very, very large amount of variation makes the mean titer less valuable. Standard deviation is an indication of how far from the mean most of the samples are. And so this is really a statistical measurement of the amount of variation that you're seeing within the flock. A large standard deviation means a large variation within the flock from that mean value. And if you have a very large sample size, you're more likely to find birds fitting around the average, which means that your standard deviation will be smaller. So the last thing we want to look at from a statistical point of view is our coefficient of variation. And our coefficient of variation is actually very tied to our standard deviation. It is used in the derivation of it. This calculates the variation of the average individual from that mean number that we looked at. And it's expressed as a percentage. So ideally, we'd like to see less than a 20% CV, but typically a target of 40% is fairly uniform.
To better explain CV, let's look at an example. This represents 3 broiler flocks, each from a different breeder flock. All of these groups have the same GMT, but a very different CV. If we neglected to consider CV, we may think that these groups have the same health situation, which is not the case. The red curve represents a very uniform flock. With expected titer response, this flock would have a very low CV. The yellow curve represents a less uniform flock, in which more birds fall outside the target titer group. This variation results in a high CV. The blue curve represents a flock of broilers that were placed in a single house. However, we see 2 blue curves because the broilers may have originated from 2 different breeder flocks, each flock with a different CV. Although it's not a good practice to mix broiler chicks from different flocks, it's not uncommon to see this in commercial farms because of the need to place chicks with certain dating. So to review what this might suggest, a low titer and low CV are indicative of no exposure to a vaccine or a field challenge, or poor response. A low titer but a high CV may indicate a very varied flock of animals, and you may want to increase the number of samples to get a representative look. A high titer with a high CV indicates a lot of variation in a flock. And finally, a high titer and a low CV may be indicative of good vaccine take when the titers fall under the expected range of the baseline. If the titer is higher than the expected range, but with the low CV still, it could be indicative of a chronic phase of a field challenge.
So in summary, variation in titers can be caused by normal biologic variation, by vaccine failure, human or instrument errors, or poor sample handling. And you, of course, always want to use correct ELISA techniques to ensure reproducibility and reliability. At this point, I hope you feel comfortable reading your statistical values that your IDEXX ELISAs generate and putting them into some context with what's happening in the flocks that they represent. So let's move forward, and we're first going to look at an example of 2 different baselines that are generated by us in IDEXX, and these are meant to be used solely for demonstration purposes. So please try to generate the numbers yourself. The first one is for IVV. You'll notice that we have on the horizontal axis the number of a flock number here, and then on the vertical axis we have the titer value. And this is similar to what you would see in an XCheck report. We've just sort of applied a grouping of high, medium, and a low titer values to where you would correspond with your titer values. It's important to note that not only are the values different between these two samples, this is a baseline for Newcastle, but the actual range within the high, medium, and low groups can be different as well. So you'll note that the high range is actually increased numerically and also increased in size here. And that's typical with different assays. So this may be what you'd see in a typical set of baselines that you would generate. In this demonstration, you'll see the test listed to the left, followed by the type of vaccine, and then what sort of a mean titer you expect for each vaccine. After it is the amount of weeks after vaccination that these should typically be tested. For a live vaccine, we recommend 3 to 5 weeks, and for an inactivated, 5 to 8 weeks. This example also shows a mean titer of day-old chicks, but you don't have to add this if you wouldn't like to. It is important to note the difference between a titer and a titer group. So a titer group is a numeric value assigned to a titer value to try to simplify the interpretation. Typically, these are 1 to 10, 1 to 20, and a large group of titers can be added within one single titer group. So 1 to 1,000 titer may indicate a titer group 1. 1,000 to 2,000 may indicate a titer group 2, and so on. You can actually subsequently then cluster those into high, mean, and low groupings, as we saw in the previous slide. The latter is far less sensitive, though, to small changes in values, and for this reason, we feel baseline tracking is better accomplished by using actual titers. So let's begin by walking through the baseline setup in the new XCheck Plus software. There are two ways to generate your data. The first, manual, means that you actually enter the manual values you wish to use as your limits, and these are typically determined between the lab and the people interpreting the information. The second, criteria, allows you to use XCheck Plus software to determine your limits based on historic data that you've generated on other flocks. The more information you enter, the more value you'll get from it. You may want to consider including the age, the bird type, the farm, etc., as this can be very important information to look at. In XCheck Plus, baselines can be tracked by titer value over time directly in the software. And you want to consider adding a naming structure to the data when you run the testing. A naming structure is something you set up once, and then you enter data corresponding to those birds via numeric code that is assigned to the grower, the farm, whatever value you'd like to be recording. We also recommend you install XCheck Plus on any computer that will be used by people evaluating the data, as this makes it easier to share the data and then to work with it as well. So let's begin by walking through the manual mode and introducing your baselines. To use the manual mode, you would open up XCheck, you would choose Database here, and then move down to Baseline Sets from the home menus. XCheck Plus does come populated with some examples. We really recommend that these are not specific enough for you to use and just use them as placeholders to show where you will put your information. Next, you'll choose New and choose the assay you wish to track. Click Select and fill in the fields for the baseline set and any comments that you'd like to add. The next step will be to enter the age groups that you'd like to divide the birds among. For example, a low age and a high age of 0 to 5 days. And then you would add in your age. Your age is automatically converted into a week-day format. If you add in 21 days, for example, it will become 3-0 for 3 weeks, 0 days. Once you've entered in the age ranges you'd like to use, click Save. You can use Add Baseline to enter as many age ranges as you would like to include in your database. Now for each age range, you'll add a low, mean, and a high titer value. The standard is the mean value. Typically, these are provided by the person who's doing the interpretation of the data, such as a company or a lab vet or your customers. Now that these are added, you'll click Save, and your baseline is ready to use in manual format. Let's move on to the criteria mode. To do this, you'll choose Database again and Baseline Sets, and then choose the Criteria tab at the top of the window. Choose New and the assay you wish to track, for example, AI here. Then click Select and fill in the fields for the baseline set name and any comments you'd like, as you did before. To use criteria mode, you'll have to define how you would like it to divide up your samples. So you'll choose the geometric or arithmetic mean, and then select min-max, standard deviation, or percent in the calculation section to tell the application how it wishes to perform the calculation. If you select standard deviation or percent, provide a value in the corresponding box, and then click Save and Close again. With this, your baseline is ready to use. For any report in which you wish to apply it, you will choose Baseline under the options, and then pick the one you wish to use, click OK, and you're ready to go. Once you've set up your baseline initially, you can assign it to various assays. The program will color code the results and give them to you in the context of the baseline. Any results which are below the baseline you indicated for the medium value will be yellow, in the medium range would be green, and the red would be high or above the baseline value you assigned. Finally, let's cover how we can track values for a baseline in Microsoft Excel. This can be done by generating a workbook and then entering mean values and inputting them over time. A master workbook can be generated, and then you'll add data from each run, which can be cut and pasted from a file saved from XCheck Plus. You may want to consider using different tabs within your workbook for various tests, and one master worksheet to compare the tests performed at the same time. You can either track your mean titer or the titer group of flocks for one data point, such as the G-mean, or individual birds, depending on the goal of your testing. Excel then allows you to generate bar graphs and line graphs and look at a number of factors. If you need more details on this, we can certainly help you through IDEX Technical Service. In conclusion, you always want to make sure that the data that you're recording is an accurate interpretation of your actual bird's status. So your first steps are always to make sure that it fits the flock expectations. The more information about the birds that you can incorporate in your baseline, the more value you'll have from your results. Use the features provided in XCheck Plus to help generate your baselines, and then use resources available in your area, such as reaching out to others in the industry, going to regional meetings, etc., to benchmark your titers against others in your region. Make sure the information you're collecting is information that will be used to make management decisions, and that economic impact will be there for your company or your customer, adding value to the testing. Now that we have completed this webinar, you should understand the whys and hows of generating a baseline, feel comfortable with general immunology as it applies to them, be aware of the first steps in test validity and basic statistics, and be comfortable building a baseline using both XCheck Plus and Microsoft Excel. Thank you so much for joining us on today's webinar on IDEX Poultry Baselines. Please contact myself or technical service with any further questions.